Okay, great. So this is the next bit. Also, another little area that's good to know and be happy with. This issue of tables, payoff tables. So let's look at the first issue. First of all, they ask us to discuss the expected values. Expected values are averages. So we've looked in the past and we've seen some information. We've been able to deduce some probability. And if you like, based on this history, we've come up with this idea that we tend to see that there's a probability of 30% that we will have 10 cases. Probability of 50% is, you can see that if out of the 50 days that were goods were sold, 25 out of 50, 20 units were sold. So you can see that's why you have a 0.5 here and 0.2 here. So they have a probability, and this is all expected values, like our decision tables, averages in effect. So the question here that we could find what the expected values would be of supplying each of these, which is what the very first question is asking you to do. So it says that how many cases should the person supply if you use the expected value criteria? So if you expected value, you literally are doing 0.3 times this, 0.3 times this, seeing what your final expected average value is. And the answer, of course, would be 100. When you do the same for that, if you supply 20 cases, you will have 0.3 times this, times 0.5 times this, times 0.3 times 10 plus 0.5 times 200 plus 0.2 times 200, and that gives you the happy number of 143, right? And then if you do 0.3 times minus 80, of course, 0.5 times 110, and 0.2 times 300. So literally, what am I saying? 0.3 and 80 plus 0.5 times 110 plus 0.2 times 300, and that gives us a happy figure of 91. So we can see here definitely that this gives us the highest average value. So based on this, we would supply 20 cases. There were never 15 cases in the first place. That was just a dummy. So we will supply 20 cases. Now let's look. Then it tells us to, let me just come here and just clear this out. It tells us that what if we were, let's erase all this. What if we were using the maximax? Sorry, I actually prefer to do max. Well, it doesn't really matter which we do first, but just to kind of remind us about how the scenario is. So the maxi-min says that, listen, I want to see what the worst case scenario would. I want the best of a worst case scenario. If I supply 10 cases, what's the worst that could happen? Well, you'll get £100. Whatever happens, you'll get £100. Whatever, it's all the same. If I supply 20 cases, what's the worst that could happen? You'll get £10. If I supply 30 cases, I'll lose £80. So I'm maximizing my worst case scenario. So the worst case scenario is that I supply this, that's the worst I get. I supply this, that's the worst I get. I supply this, that's the worst I get. So I'm going to pick this one because at least I get £100. So that's why 10 cases is the answer. So maxi-min is about worst case scenario, maximize the worst case scenario. Maximax is brilliant. It literally is who's giving us the highest. I'm going to go for that. I'm going to be entirely optimistic. I'm going to go for 300, and that's with 30 cases. The regret table. Now you need to draw the table. It doesn't pop out. If you do the minimax regret, you actually have to draw a table to see what the situation is. So what does it mean? So here's what we're saying. That if the demand is 10 cases and you supply 10 cases, well, there is no regret. I'm going to draw my table here. There is no regret. So I'm just going to go 10, 20, 30. But if the demand is 10 and you supply 20 cases, well, you have lost 90 because you're only going to get 10. If you supply 10, sorry, if the demand is 10 and you supply 80, the best you could have gotten was 100 and you got 10, so the regret is 90, if you like. And here, the regret is minus 80, so really the regret is actually, you're going from 100 to 80 to minus 80, which is actually 180. That's the regret, right? That's the regret. It's unfortunate. That's what you've lost. Look at this next case. If the demand is 20 and the best case, the best case of course is that the demand is 20 and you supply 20. So there is no regret there. You always start from that point. But unfortunately, if the demand had been 20 and you only supplied 10, well, unfortunately, your regret is you've lost out on 100. And if you had supplied 30, well, you'd have lost out on 90. And then let's look at the case 30. Well, of course, there's no regret there. Well, here, of course, you will lose 100, and here you'd have lost 200. So the question here is, we look for what is the highest, what is the worst regret here? The worst regret here in this case is 200. If you supply 10, the worst regret here is 100, and the worst regret here is 180. So we want to go with the one that has the least regret. We don't want to regret. So we were going to go. This is the one with the lowest. I mean, out of you literally look down the table to review the regrets, if you like, at each chances of those supply or those demands, and you pick that, and you will see that you arrive at that. Yes, exactly. So because this is your lowest regret, you're going to go with 20 cases, right? You're going to go with 20 cases because that gives you the lowest regret overall, if you like. So so the answer there, 20 cases, is C. And finally, the following cases, expected values are average values, right? Average values. The expected value may not be a possible outcome. An outcome is actually what happens, and that's true. It just may not. It's just an average, so that's true. It is an average value that may not be useful for a one-off project. That's true. I mean, if you're only going to toss a coin once, it's difficult to say that based on what's happened in the past, it will be heads or tails. It's a one-off project. We don't know, so that is true. And with expected values, the spread of the outcomes, we only have one result. We don't know what the different potentials are. We just arrive with one final value. So that's also true as well. So all the statements are correct. Cool. Great stuff. That's those 5 questions. Let's move on to the last 5.